Example that we'll do is the one at the top that says how many molecules are in 25 grams of salt. And the thing that I want you to recognize is that there is a relationship between molecules and moles. We know that there are 6.02 times 10 to the power of 23 molecules in 1 mole. And so anytime a question asks you about molecules or tells you about molecules, the first thought that should come into your head is that molecules and moles have a relationship. If I knew how many moles I had of something, I could calculate how many molecules I have of something. And so see how the word molecule has the word mole right in it? That's like a nice verbal cue that if I ask you about molecules, what I'm really asking you is figure out how many moles there are and then convert that into molecules. So I'd like to show you that the first part of this question is not different from what we did yesterday. The first thing I would do, I would say salt. What on earth is that? It's sodium chloride. And I would start by figuring out what's the molar mass of this substance. So my substance is NaCl. What's its molar mass? 22.99 plus 35.45. It gives you 58.44 grams per mole. If you weren't impressed that I knew all of that off by heart, you should be. It's quite impressive. Yes. That is the mass of chlorine. So the 22.99 came from sodium, and the 35.45, that's the mass of chlorine. Yes, Ryan. No, but the things that we use often, yes. So I know, for example, that calcium's 40.08 and potassium's 39.10, fluorine's electronegativity is 4, like I know all that. Its molar mass is 19. It's just in my head. I've used it. But think about this, though. What year were you guys born in? 1999? 2000? I was done high school then. So I've been using chemistry longer than you've been alive. So take it with a grain of salt. So that's the first step, same as what we did yesterday. Next thing is that we know, because I just told you, if I ask you about molecules, what I'm really asking you is find out how many moles there are first. So I'm going to calculate how many moles there are. I have two choices. I could use the formula, or I could make units cancel out. Whichever you prefer. If I use the formula, I'm going to take 25 grams and divide it by 58.44 grams per mole. If I use the unit canceling method, I'm going to take 25 grams and multiply it by the ratio between grams and moles. I know that for 1 mole, there is 58.44 grams. Now, up until that, this is all what we did yesterday. And so I'd like to ask, does anyone have any questions about any of those steps, like where a number's coming from or why I did a particular thing? So we will get an intermediate answer. And I'm calling it intermediate because this is not the end of the question. If you're going to calculate an intermediate answer, you don't round it off. You would never round something until you're done doing your whole entire calculation. So I would do 25 divided by 58.44. It gives me 0.427789 blah, blah, blah moles. Now, most calculators have a function that will let you take the answer you just calculated and use it again. On my calculator, which is a TI button, if I press second function and the little negative button at the bottom, it brings back the answer that I just calculated. That will save you the trouble of having to retype all of those decimal numbers. And if you're unsure how to do this on your calculator, or if your calculator does it, later on when everyone's working, I'll walk around and check out your calculators. Not everybody has the same one. And so sometimes me telling you how to do it on your calculator has no meaning to you because your calculator is different than mine. Now here's where I have to add something. This question did not ask me how many moles there are. It asked me how many molecules. I started by calculating how many moles, and now I'm going to take that to molecules. Now, unfortunately, there's not a formula for this calculation. There's not one that exists. It's not on the formula sheet. So you really need to think about units here. There are 6.02 times 10 to the power of 23 molecules in 1 mole. But that's not how much I have. I have less than 1 mole. So the idea would be, if I know how many moles I have, I just multiply that by Avogadro's number, because that's how many molecules there are in 1 mole. Now if you notice, what I'm really doing is making the units cancel out. I started with moles. Moles would be on the bottom of that ratio. But when you want to know how many molecules you have, you'll take the number of moles and multiply it with this constant. That number is on your data sheet, so you don't have to memorize it, but you do need to know what to do with it. Now here's the next little bit that I'd like to show you. I'd like to show you how you type this number into your calculator, because it's not the same for everybody. When you type this number into your calculator, you would of course start by typing 6.02, and then the next button you press is different for everybody. If you have a TI calculator and a TI 83 or 84, one of these bigger ones that you use for math, the button that you're going to look for is the one that has 2-letter E's. On my calculator, this is second function, and then it looks like a little comma. It's right above the number 7. So on my calculator, this is where it is, right above the 7. So I would press the blue second function button, and this button above the 7. There's 2 little capital E's over it. That button represents times 10 to the power of. So I don't have to type that. In my calculator then, this is what I would type. 6.02, second function, the button above the 7, shows an E, and then 23. I don't have to type the times. I don't have to type the 10. So this EE button takes the place of times 10 to the power of. Now for some of you maybe who have a less fancy calculator than a TI 83 or 84, sometimes what you're looking for is a button that says EXP, or sometimes 10 to the power of x, but it's almost always a second function. So where you would press shift or second function, and it'll be one of the extra things that your calculator does. So those are the things that you're looking for. If you don't have this calculator and you're at a loss for where to find that button on your calculator, I would be happy to come and show you later on where it is. The last thing that I'd like to mention is that it's not necessary for you to say, write down your intermediate answer, because you know that you're going to keep on calculating. And so, for example, as work, I would accept if you just wrote this, you left this out, but you wrote that part as well, because that's the work that you're doing. So I don't need to see your intermediate answers. You can just show me the calculating that you were doing. The last thing then that we would do, so we'd take our 25 divided by 58.44 number. And then we would multiply that by 6.02 times 10 to the power of 23. That gives us 2.58 times 10 to the power of 23 molecules. Now, if you're doing this on your calculator does not say times 10 to the power of 23. On my calculator, what I see on the screen is 2.575290897 E23. So you have to look at the end of the decimal and check to see if there is an E. The E represents times 10 to the power of. So when I read this on my calculator and I see at the end it says E23, that means that this is my answer times 10 to the power of 23. So you really have to understand what your calculator is showing you here. Just because your calculator says E doesn't mean that's what you should write. That's calculator buttons. That's not actual numbers. When you're writing things down, you need to actually write times 10 to the power of. So before we go any further, all right, so in the second example, I'm asking you not this time how many molecules there are. That's not the answer we're looking for. I'm telling you how many molecules there are, and I'm asking you what is the mass. So just like in any other question, before I think about molecules and moles, I'm going to think about my substance, and I'm going to think about what its molar mass is. So first things first, calcium chloride is CaCl2. Calcium is +2, chlorine ions are -1. So when I swap and drop, I get CaCl2. Someone want to open the door for April there? I think the handle might be locked. The second thing that I want to do then, before I do any other calculating, is figure out the molar mass of my substance. Calcium's atomic molar mass is 40.08. Chlorine's is 35.45 times 2. So the overall molar mass that we should get is 110.98. Now this is grams per mole. Now that I've done those two steps, I can ask myself, okay, how am I going to calculate my answer? It's asking me what's the mass of some number of molecules. Molecules isn't part of any formula that I know, but I do know that molecules and moles have a relationship. In this case, I've already told you how many molecules I have, and I'd like to know how many moles that represents. So the next thing that we'll do, before we do any formula calculating, is figure out how many moles we have. I have 4 times 10 to the power of 23 molecules. And I need to ask myself, how am I going to get that to moles? Well, when I knew moles and I wanted molecules, I multiplied them together. And so since this is the opposite of that, I'm going to divide them. I'm going to take the number of molecules I have and divide it by 6.02 times 10 to the power of 23 molecules per mole. When you think about this, I'll make an analogy to something that's a number that you can be more familiar with. Let's say, for example, that instead of moles and molecules, I was talking about dozens of donuts. That's a more reasonable number to think about. That would be like me saying, hey, I have 6 donuts. How many dozen does that represent? And you would say, well, in every dozen, there's 12. And so if I said I have 6 donuts, how many dozens do I have? You would say, well, 6 divided by 12 is 0.5. I have half a dozen. And so if you know how many total you have, total molecules you have, and you want to convert that to moles, you need to divide by Avogadro's number. So that means that the first step here, before we do other calculations, would be to do 4 times 10 to the power of 23 divided by 6.02 times 10 to the power of 23. It tells me 0.66 moles. I'm not going to write the whole decimal just because I would run out of space, but keep in mind I'm not rounding my number off there. It's actually 0.6644518, and it goes on. Now that I know how many moles, I could figure out the mass. Mass is moles multiplied by molar mass, if I'm using the formula. So I would take 0.66, etc. moles, and multiply that with the molar mass, 110.98 grams per mole. That's how I would get my answer, which is 73.7 grams.